Welcome, learners. Today we are going to learn about the inverse Laplace transform, how to solve the problems using inverse Laplace transform. Take down the first problem. Find L inverse of 1 by S minus 3. We know that L inverse of 1 by S minus A is e power at. Therefore, we can write L inverse of 1 by S minus 3 is e power 3t. Now come to the second problem. L inverse of 1 by S square plus 25. Here we are going to make use of the formula. The inverse Laplace transform of A by S square plus A square is sin at. To make use of that formula, whatever A present in the denominator, the same A should be present in the numerator also. Here, by considering A equal to 5, 5 square gives you 25. Therefore, 5 is missing in the numerator. So, multiplying and dividing it by 5, we are getting 1 by 5 L inverse of 5 by S square plus 5 square. That gives you 1 by 5 sine 5t. Now we'll move on to the third problem. Find L inverse of 1 by 3s minus 7. Already we have seen the problem. L inverse of 1 by s minus a is e power at. In the place of s, we are having 3s here. So taking 3 common as a constant, it will give you 1 by 3 into 1 by s minus 7 by 3. Therefore, in the place of a, you are having 7 by 3. So by making use of this formula, 1 by 3 e power 7 by 3 into t. Now, we'll move on to the next problem. Find L inverse of s by s square plus 9. It's a direct formula. We are having inverse Laplace transform of s by s square plus a square is cos at. Therefore, L inverse of s by s square plus 9 is cos 3t you will have. Now, we'll move on to the next problem. Finding L inverse of s minus 1 by s minus 1 the whole square plus 4. So here s is replaced by s minus 1. Therefore, we are going to make use of inverse Laplace transform of first shifting theorem. Inverse Laplace transform of first shifting theorem. What is that? You know, L inverse of f of s minus a is e power at into L inverse of f of s. So you are having L inverse of f of s minus a equal to e power at L inverse of f of s. By making use of this formula, in the place of s, we are having s minus 1. So a equal to 1 here. Therefore, e power t L inverse of s by s square plus 2 square. So you're having e power t cos 2t. Now come to the next problem. We are going to make use of same first shifting theorem only. Here we are going to make use of the formula L inverse of f of s plus a equal to e power minus at L inverse of f of s. Therefore, e power minus 3t L inverse of 1 by s square plus 2 square you are having. Since you are having constant in the numerator, it is resembling with the formula of sin at, that is a by s square plus a square you have to have. So it will give you e power minus 3t. Okay, s plus 3. You are writing e power minus 3t into L inverse of 1 by s square plus 4. That gives you 2 is missing in the numerator. So multiplying dividing by 2 will give you e power minus 3t into sine 2t by 2. Next, we are going to move on to the problem finding L inverse of 1 by s minus 2 the whole square minus 25. So same first shifting theorem only we are making use of. L inverse of 1 by s minus 2 the whole square minus 25. Here the denominator you are having minus sign. So for s minus 2 we are writing e power 2t. L inverse of 1 by s square minus 5 square. E power 2t. This is the formula for sine hyperbolic. 5 is missing in the numerator. So multiplying dividing by 5, you will get sine hyperbolic 5t by 5. Now next problem. Find L inverse of s plus 2 by s square plus 4s plus 8. Here if you are seeing the denominator, you can express it as s plus 2 the whole square plus 4. Numerator is also s plus 2. So s plus 2, here also s plus 2, therefore it can be written as e power minus 2t L inverse of s by s square plus 2 square. The formula for L inverse of s by s square plus a square is cos at. So a equal to 2, therefore e power minus 2t cos 2t you will get. Now next problem, find L inverse of s by s plus 2 the whole square plus 1. Here if you are seeing the numerator only s you are having, but in the denominator you are having s plus 2. So to make it in the form, the numerator, in the numerator, we are going to add and subtract 2. So by adding s with 2, you will get s plus 2 minus 2 by s plus 2 the whole square plus 1. Therefore, by making use of linear property of inverse transform, you can split these terms as L inverse of s plus 2 by s plus 2 the whole square plus 1 minus L inverse of 2 by s plus 2 the whole square plus 1. Then make the first shifting theorem formula e power minus 2t L inverse of s by s square plus 1 minus, here s is replaced by s plus 2, therefore e power minus 2t L inverse of 1 by s square plus 1. So L inverse of s by s square plus 1 is cos t into e power minus 2t minus 2 times of e power minus 2t into the formula for this is sin t. I think you can able to understand it. Now we are going to move on to the next problem. Find L inverse of 1 by s power 3. So we all know what is the formula for L inverse of 1 by s power n. When n is an integer, you are having the formula t power n minus 1 by n minus 1 factorial. This you can apply it for n is an integer. So here also n is an integer, n equal to 3. Therefore t power 2 by 2 factorial, 2 factorial is 2 itself. So we are getting the answer for L inverse of 1 by s power 3 is equal to t square by 2. Suppose if you are getting the problem, find L inverse of 1 by s plus 2 the whole power 4, then you will get The answer is L inverse of 1 by s plus 2 the whole power 4. By making use of first shifting theorem, you can write it as e power minus 2t L inverse of 1 by s to the power 4. So now by making use of the formula, here we have it is going to be e power minus 2t, okay, t power 4 minus 1 by 4 minus 1 factorial, which gives you e power minus 2t into t power 3 by 3 factorial. This gives you e power minus 2t into t cube by 6. Hope you all understood. Thank you.